In this video today, we are going to look at the matrix essentials for Form 4 and Form 5. Right? First of all, we will take a look at the order of a matrix. Right? Its form, right? Whether it is this type, right? Or any other types that may be applicable. Right? Number 2, we're going to look at the addition of matrix. Number 3 would be the subtraction of matrices. Then we'll look at the multiplication of a matrix by a number. Then after that, we'll take a look at the multiplication of two matrices. Alright, we'll look at the identity matrix and inverse matrix. Right, the order of matrix, the first one, a matrix with m rows and n column is a matrix of order m times n. Right, for example, the first one, we've got the 3 1 here. All right, the matrix of the order is 2 times 1, which means that there are 2 rows and 1 column. 1 row, 2 rows and 1 column. All right, next one is a matrix of order 3 and 2. Right, there are 3 rows and 2 columns. 1, 2, 3 rows and 2 columns. So now we'll be looking at the addition of matrix. In order to add matrices, right, these matrices must have a similar order. Right? That means if it is a 2 times 2, then you have to have a 2 times 2 as well. Right? A 2 times 2 can only be added with a 2 times 2. A 3 times 2 can only be added with a 3 times 2. Okay. Let's take a look at how we add the matrix. A plus P, we've got A or rather A plus P, then B plus Q, B plus Q, C plus R, C plus R, D plus S, D plus S. All right, so there are still 2 rows and 2 columns. Okay, so your resulting matrix is still 2 times 2. Okay, the next one, 2 plus 5 would be 7. 3 plus 8 would be 11. 4 plus 3, 7. 5 plus 7, 12. Okay, this is still your order. The order of matrix will be still 2 times 2. Right? 2 rows, 2 columns. Next one, 2 plus 2 be 4. 3 plus 3 be 6. 4 plus minus 1, 3 minus 1 plus 2, 1. 6 plus 1, 7. Minus 2 plus minus 4, minus 6. Right? Your order of matrix is still 3 times 2. Right? 1, 2, 3 rows and 2 columns. Okay, for subtraction of matrices, they must also have similar orders. Right? Have similar orders. That means it's 2 times 2. You can only minus with another matrix of 2 times 2. Right? You cannot have different matrices that you can minus. Right? Make sure that they are the same. Right? The first one is A minus P, B minus Q, C minus R, D minus S. Right? Your matrix is still 2 times 2. Right? 2 rows and 2 columns. The next one, 2 minus 1, you get 3. 4 minus 3, 1. 3 minus 2, 5. 7 minus 4, 3. Your resulting matrix is still 2 times 2, right? 2 rows, 2 columns. Right. Next one, you look at the multiplication of a matrix by a number. Right. This is your matrix. This is your number. So if you multiply in, right, you will get Ka, Kb, Kc, Kd. Right. We look at the one with the number 2 here. Right. 2 times 3, 6. 2 times 2, 4. 2 times 4, 8. 2 times 5, 10. Right. Then number 3. 3 times minus 3, minus 9. 3 times 2, 6. 3 times 5, 15. 6 times minus, 3 times minus 6, minus 18. Next, we take a look at the multiplication of 2 matrices. Right, if we look at the form of the matrix, right, here we have a 1 times 2 matrix, and this is a 2 times 1 matrix. Right, the inner part of the form, right, must be the same. Right, this is 2 columns, 2 rows. All right, this has to be the same in order for you to do a multiplication. And the green one will be the resulting matrix. Right, let's take a look at how we approach this. Right, A times P, AP, B times Q plus BQ. This is a 1 times 1 matrix. 1 row and 1 column. Let's take a look at the next one. 2 times 4, 8. 3 times 5 plus 15 will be equal to 23. All right, this is a 1 times 1 matrix. Right, 1 row, 1 column. Next one, minus 2 times 2 minus 4. 4 times 3 plus 12 be equals to 8. Right, this is a still 1 times 1 matrix, where it is 1 row and 1 column. Move to the next one. This would be a 2 times 1 matrix times by 1 times 2 matrix. All right, this is 2 rows, 1 column, 1 column, 2 rows. You take a look at this column and this row are the same. All right, So this would be your resulting matrix. Your resulting matrix would be like this. Okay, and let's take a look at the examples here. A times P, AP, A times Q, AQ, B times P, BP, B times Q, BQ. Okay, your matrix is a 2 times 2 matrix. 1 row, 2 rows, 1 column, 2 columns. Next one, 2 times 4, you have a 8. 2 times 5, 10. 3 times 4, 12. 3 times 5, 15. Okay, 2 times 2 matrix. 1 row, 2 row, 1 column, 2 columns. Take a look at the next one. 3 times 5, 15. 3 times minus 4, minus 12. 2 times minus 2 times 5, minus 10. Minus 2 times minus 4, 8. Right, still a 2 times 2 matrix. 1 row, 2 row, 1 column, 2 columns. We'll go to the next one. So we are using a 2 times 2 matrix with a 2 times 1 matrix. Right, the column and row has to be the same. All right, this will be your resulting matrix is a 2 times 1. That means it's this format, right? 2 rows and 1 column. All right, let's take a look at how we approach this. A times P, AP, B times Q plus BQ. C plus P, CP, D times Q plus DQ. Okay, this is your matrix of 2 rows times 1 column. 1 row, 2 rows and 1 column. Okay, let's take a look at the next one. 1 times 2, 2. 3 times 3 plus 9. 2 times 2, 4. 4 times 3 plus 12. Be equal to 11 over, 11, 16. Right, this is your matrix of 2 rows times 1 column. 1 row, 2 row and 1 column. Next one, minus 1 times minus 3, 3. 2 times 2 plus 4. 3 times minus 3 minus 9 minus 4 times 2 minus 8. So your resulting one would be 7 minus 17. Right? This is also a 2 times 1 matrix. Right? 2 rows and 1 column. Okay, we take a look at the next area. Right? This is a 2 times 2 matrix times by a 2 times 2 matrix. Right, let's take a look at how we can approach this. Right, so your resulting matrix would be a 2 times 2. Okay, A times P, AP, B times B times R plus BR A times Q, AQ, B times S plus BS. Then the C times P, CP, D times R plus DR. Right. Then the C times Q, CQ, D times S plus DS. Right. This would be the resulting matrix is a 2 times 2. Right. 1 row, 2 rows, 1 column, 2 columns. Let's take a look at the next one. 1 times 2, 2, 2 times 3 plus 6. Okay, then 1 times 4, 4, 2 times 5 plus 10, 3 times 2, 6, 4 times 3 plus 12. Then 3 times 4, 12, 4 times 5 plus 20. Right, so your resulting one would be 8, 6 plus 12, 18, 4 plus 10, 14, 12 plus 20, 32. Right, this is a 2 times 2 matrix, 1 row, 2 rows, 1 column, 2 columns. Right, take a look at the next one. Minus 1 times 2, minus 2, 3 times 3 plus 9, 1 times minus 4, 4, 3 times minus 5, minus 15. Two times 2, 4, 4 times minus 4 times 3, minus 12. Then 2 times minus 4, minus 8, 4 times minus 5 plus 20. Right? Your resulting would be 7, 4 minus 12 is minus 8, 4 minus 15 minus 11 minus 8 plus 20 would be 12. The resulting matrix is 2 times 2, 1 row, 2 rows, 1 column, 2 columns. We move on to the next one. The next one talks about the identity matrix. If you have a matrix A and you times by the identity is the same as the identity times by the matrix A. Alright, both will be equal to A. Alright, that means whatever matrix that you have, you times by the identity, you arrive back at the original matrix. Alright, some of the identity matrix, right, are this one, right, in this form 1 0 0 1 0 0 1 for a 2 times 2 matrix, and a 1 0 0 0 1 0 and 0 0 1 for a 3 times 3 matrix. Alright, let's take a look at the first one. So let's say if you multiply this matrix with this identity, right, what would be the result? Right, you have this is 1 times A, which is A, 0 times C plus 0. Then you have 1 times B, it's a B, 0 times D plus 0. Then 0 times A be 0, 1 times C plus C. And the next one, 0 times B, you have a 0, 1 times D plus D. Okay, so your resulting would be A, B, C, D, right? So this is your resulting matrix. This is your original matrix. So you get back the same result. Let's take a look at one example with a number. 1 times 2, 2, 0 times 4 plus 0. 1 times 3, 3, 0 times 5 plus 0. 0 times 2, 0, 1 times 4 plus 4. Right. 0 times 3, 0, 1 times 5 plus 5. Alright, you're resulting 2, 3, 4, 5. Right, this is your resulting matrix. This is your original matrix. Right, they are the same. So whenever you times a matrix, with a identity, you get back the original matrix. And finally, we take a look at the inverse matrix. So if you have a matrix of this format, A, B, C, D, right, then the inverse of A is written as A to the power minus 1. Right, this would be 1 over A times D minus B times C. Alright, then inside here, alright, you reverse the position of this numbers, right? Then you change the sign of this minus B, and minus C. So when AD minus BC is not equal to 0, then the AD minus BC is known as the determinant of A, right? For the moment, you just know that this is called the determinant of A, all right? This portion is called the determinant of A. So if this inverse of matrix A will not exist if the determinant is 0, right? That means if AD minus BC equals to 0, then that particular matrix will not have an inverse matrix. Alright, we will look at some questions later on to fully explore what is inverse matrix. Right, then finally we do a review of what we have done so far. Right, we have take a look at the order of a matrix. Right, if it is a 2 times 3 matrix, if it's a 2 times 3 matrix, then you have 2 rows and 3 columns. Right, for addition and subtraction of matrix, the order of the matrix must be similar. If they are not the same, then you cannot add or minus the matrices. Then we look into multiplication of matrices. Right, the numbers of the columns of the first matrix must match that of the number of rows of the second matrix. Only then you can do a multiplication. If not, the multiplication cannot be done. Right, then we took a look at the identity. Right, the identity of a matrix. Right, the identity times by the matrix, or the matrix times by the identity, you should get back the original matrix. And then finally we look at the determinant. If a determinant of a matrix is 0, right, that means there is no inverse matrix for that particular matrix. Right, the determinant is defined as AC minus BD. That means there is A times C minus B times D. All right. So after this video, right, you attempt the questions that I will be forwarding to you, and hopefully you understand what the matrices is about. So if at any point of time that you feel that you still do not understand, relook at this video, right? Then you should be able to approach your questions appropriately.